Okay, welcome to the data ingestion process and tool section of the Snap4City 2020 course. In this section we are addressing all the issues for data ingestion process and tools, and thus the content of this section is take for granted the aspect of a general overview, the fact that the system can have some dashboard for representation of the data and results, the fact that you know how to create an IoT application, how you can connect the device, how you can have IoT networks in your premise, how you can have you can develop some data analytics, for instance, in RStudio or Python, and you can exploit some data analytics and data processing also in IoT applications. So we address in this part data ingestion, data warehouse, the exploitation of the data gate with the CKAN, and the usage of IoT application for data ingestion. So the structure of the agenda is reported in this slide. I'm not going to read everything, but you can, in the interactive version of the slides that are available on the portal and the page of the course, you can click on the Go, in the Go button, just to jump to a specific section of which you are interested. So, a short recall about the mechanism. So you know that there are a number of operators that provide the data in the smart city, and these are data collected from mobility operator, transport, energy, tourism, and also governmental data. All this information can be collected in a layer for the Smart City engine, and the Smart City engine could provide this information through APIs, for instance, to SME or other small medium enterprise and other applications. In the same manner, the Smart City engine with the Smart City APIs can also provide this information to mobile app and totem and services for the final user. At the same time, final user can be used to provide you data, and the Smart City engine can exploit the data, can produce derived data with data analytics and so on. So to provide support towards the stakeholder, for instance, dashboards, or the final user, for instance, totem or touch screen for services or web pages, but also mobile app. So in this context, we are talking about the data ingestion process that in the flow of the Living Lab acceleration and in the setup of the smart city, that part is a basic part that allows to create the infrastructure, to set up the infrastructure with the needed data inside the smart city platform. This is not something that is confined only at the beginning of smart city setup or platform setup, because the addition of new data is a continuous process. Every day, every week, you have new data, and you need to update the process for data ingestion, but also you need to add more data, and more data are coming, and more sophisticated data can be added to the platform. So that the mechanism of data ingestion is something that you have to put in place as a regular and a stable process for inside your smart city. Solution analysis and design. So what is the solution? The solution is what you are going to develop to produce some smart solution. You need to perform an analysis and design process that include also data discovery, that could be available in your area. Sometimes the data that you have in place are not perfectly don't perfectly fit on what you expect, but in most cases it's possible to find in the same area data that can surrogate with respect to the data that you are looking for. So it's possible to do it. This phase of innovation and the identification of how to solve this problem, which kind of data are needed, which kind of infrastructure you can set up to enforce an innovation or a new smart service in your application, in your smart city, is frequently passed through the analysis and discussion with the stakeholders, as we usually do. In this sense, Snap4City Innovation Matrix and Process that is more described in the course part 6, but not described in details in this full course, because it's a part quite articulated and complex to be presented in something like an online course. So what happens usually? Usually we manage a number of workshops with your stakeholder, with a filling tables such as the one reported on the left side, in which the current conditions are analyzed and the hypothesis on the new way of managing some services, or the new smart system, smart solution could be put in place to analyze if the new smart version could be, let's say, put in place and could be accepted by your final users. This is a very relevant, very important, because you can invent very innovative solutions, but if they are not accepted, they are not acceptable by your customer segment, and the customer segment you identify, the solution would not be used, and you are going to spend time and effort for nothing. So to give you an idea of which kind of enabling data could enable your smart solution, for instance, for smart parking, you need to have a parking location, real-time parking data to provide at risk prediction. But if you have more, like such as data regarding environmental data, but also traffic flow, but also weather prediction and so on, you can be much more precise in estimating parking prediction, for instance. The same for routing. You may have basic information for GIS, but you need to have precise management and precise information on how to manage the left-right turn or the sides of the street and so on. If you would like to realize a routing for special travel means, you need to have more details. If you would like to arrange some dynamic routing in a way that your ambulance or your fire brigade can take the right path in the right moment, is obviously another issue. So you need to have much more precise information regarding the real-time data in that moment of your city. So these are offered to you just as examples. I am not going to look at all of them, but it's just reported a couple of examples to give you an idea of the complexity of foreseeing a smart service in advance without implementing. So we have a large experience in implementing those kind of smart services that can really make a difference in immediately identifying in a snap sites with a similar data. This was mainly on public transportation, The second one is related to the user behavior, to the weather and environmental, etc. So the data ingestion capability and architecture is reported in the next section. So next section is focusing on this part of the data ingestion. So data discovery means to understand which kind of data you may have in the area, while this part of data discovery is less technical, but very, very sensitive activity. There is also a more technical activity of data ingestion that you have to keep in parallel, because once you have identified the data, you have to verify that the data can be ingested maybe automatically, or maybe acquired in some ways, or can be taken from in terms of license, or can be taken with some technical mechanism, with a real-time download of the data, or you can connect with some service, or you can ask for a database, and so on. This is the problematics for data ingestion. So you know that in the platform, data ingestion is related to all the connectors that we have. All the connectors are bidirectional. So we ingest data, but we also are capable to send data to this service. This means that when you contact someone to have the data, you can offer other data back, which are the results of what you are going to elaborate, what you are going to produce inside the smart city. So there are a number of standards, and the Snap4City is interoperable with all of them. I am not talking about them. We have already talked about this aspect, and now it is the fifth slot, so you know more probably on these things. More in details, formats. We never talk about the formats. The formats is also a way to exchange the data, but the data have a specific format. The protocol is the manner how this data arrive, but the format could be different in different protocol, or the same format can be adopted in different protocol. So the Snap4City is also compliant with the many formats like JSON, GeoJSON, XML, HTML, HTML5, DATEX. DATEX is typically for transport system, GTFS for transport system, etc. So we are compliant with almost all formats. Are not reported all here because it's not possible to do it. So you can go at this link, follow this link to have more details, or drop us an email if you have some doubts about the possibilities of using a certain format inside the platform. So just to remind, these slides, you have already seen these slides in another section before this one. So we ingest the data from any kind of these data sources, and all the data is bidirectional and collected inside the platform. So you know that the aim and the general aspect is to bring inside the storage data, and the data can be manipulated with the IoT application, in which you can exploit also data analytics to arrive at the dashboard. We are talking in this section about the mechanism to bring the data inside. So for the readings, this is offered to you if you would like to go in deep in the aspects of general overview for the system, from create a dashboard to the IoT model, including what we are going to present in this section as well. So some further reading. In these slides, when you see some text highlighted in yellow, means that that part is alternative to the mainstream, or is referring to the legacy solution. We considered the whole activity related to the development of processing by using ATL, extract, transform, load process performed, for instance, in Spentau Kettle as a legacy, as something that is going to be step by step deprecated. In some cases, there are some cities, they continue to ask us to use that kind of approach for data transformation because they have a back office tuned with ATL process. So Snap4City is compliant with ATL. So for many years, we have used that kind of approach. Now we are pushing more the IoT application in Node-RED plus Snap4City libraries and microservices because it's much more powerful than the ATL. So again, references to your self-training. So data ingestor architecture and tool is starting from here. So again, this is the architecture. We are talking of this part here is mainly focused on how the data can be taken from your servers. The data can be taken in pull or in push. So the data can arrive to some port in listening, or we can go to take the data from your server. Modality for data ingestion. So once you start with the new smart city, the first step absolutely is to understand if you need to have a semantic model behind your map. Semantic model behind your map means that you have a map that is not only an image, but you can click on the elements in the map and at least to identify the roads, road segments, elements, and civic numbers, and region or parts of the maps that is there. So to add, you can for the maps you can use a lot of. There are a lot of maps resources free of charge that you can exploit, but and also for the semantic model behind the map, you can use some data that you may have from your geographic information system, or or you can merge. You can take the semantic information from OpenStreetMap. The Snap4City tool provide tools for ingesting maps and semantic information from your GIS or your OpenStreetMap. Usually we start from an OpenStreetMap to set up your region area, and with a very fast process. In a few hours you may have everything set up, your area and your geographic information structure in terms of roads and main roads, secondary road, tertiary road, the crossroads, all the other information and buildings, maybe if they are. So this is the first step. As a second step, you can start ingesting data. Data can be in any format, in any protocol, as mentioned before. Can be structured and unstructured. That means to be table or JSON or text. Can be static data or real-time data. Static data can be descriptors of, let's say, point of interest or a position of the sensor or position of your point of interest or open data that you may have collected in some CKAN and so on. These are the static data. The other static data may came of other kind, may came from GIS, so the shapes of a garden, the path of a cycling path, the path for your transportation in GTFS, the heat map of hot places, the heat map of your environmental data, the tracks and trajectories of your people in the city, and so on. All this kind of data can be obtained, can be taken into Snap4City and managed. At the end, you may have also real-time event-driven data, so the data that arrive from sensors, and so this data may arrive in the platform with different rates. Maybe some of them every 2 minutes, other every 5 minutes, traffic flow 5 minutes, environmental data maybe every 10 minutes, or a prediction, meteorological prediction every 6 hours, and so on. So in any case, they are real-time data. Other example could be the number of people passing through a cameras, or number of people detected by a PAX counter, condition of a bridge, vibration, or condition of number of, so the noise of a given area, the intensity of the light, the humidity in the garden. So they are measured with different frequency. All of them can be taken. You can also take some web scraping you can also take data from some web page by using web scraping process. You can take almost any kind of data you may have in your area with Snap4City tools. Okay, so static and versus dynamic information. Please take in mind that most of the available data are available in the terms that they have a value for the user that would like to exploit, that would like to know which is the status of the parking, that would like to know which is the status of the traffic in the city, and so on. So most of the available data for the final user are real-time data. Real-time data could be cumulated and create historical data. Historical data are also very valuable for the city because they would like to create some prediction model, or they would like to understand and to know how the city is used, how the service is used, and so on. So most of the real-time data are the most valuable data that you may collect. So static data regarding how the city is configured, where the service are typically accessible in many different manners for the users, and the users are not very demanding of this kind of service, because they can really have this information from many different apps, from many different services. So they can use Google to browse and to see what is around, but maybe they don't have the information of the traffic precise, they don't have information of the status of the parking, they cannot interact with the smart light, and so on. Okay? So typically real-time data means that they have a part of static information, so at the level of collection. So there is a collection of devices representing a certain service. For instance, a smart park or a smart light could have a smart lighting, for example, in an area, in a garden, you have 100 different lights. That is the collection of device. You know that this collection of lights device are managed all together with one single license, with one single credential, with one single frequency of the update, and so on. So you have information at the level of collection of device, and you have for each device a static information associated to it. For instance, the structure of the data assigned to that device, the GPS coordinated associated to that device, the kind of information you have, so nature, subnature, healthiness criteria, mean time to failure, so all the information which are associated to that device, even the builder, or who is the guy that you have to call if something is getting wrong in that device, etc. In addition, you may have dynamic information attached to the device, and dynamic information arrives typically in push in the system every 5 minutes or every 10 minutes according to what you have set up. Typically, the real-time data arrive inside your platform through a gateway or a sort of brokers that collect the data from the field, from the device, and aggregate them and send them. And so you can you can call the gateway to collect this data, or the gateway can send you the data as well. So static information for each collection of device and device have to be loaded in advance. Dynamic information has to be connected to the static information at the ingestion time. So connected at the ingestion time. When the data enter in the platform, a number of information has to be created. So you have to create the historical data storage. You have to create the data shadow of the. You have to derive eventual data. For instance, the derived data from the format data. You may need to calibrate data. You may need to change unit for the data. You may need to reorganize the data once the data are ingested, because the data are when entering the platform need to be associated to the specific element that you have in the city. So all these aspects are managed in the first part of the Snap4City architecture, and we are going to see how the specific mechanism in the next slides. Data in general are not so simple as one can imagine. A lot of data arrive in the platform. A large number of data types and sources have to be managed. You can and only thinking that the data arrive in the platform are those that may arrive through a brokers is a wrong hypothesis, because you may receive data from external services, from heat map, trajectories, maps, origin, destination, matrix, actuator, personal data, KPIs, API description, special widget, events, prediction. So you have a real large set of heterogeneous data, and you need licensing for manage all of them. And this kind of variability in Snap4City is called high-level type. So high-level type. Take in mind that these acronyms, because we are using inside the platform to really address them in a uniform manner. So the high-level types are reported here on this table. And you see this high-level type classified in mainly static data, point of interest, mainly data that can have a time series and are real-time and dynamic, such as a sensor or sensor actuator, or a KPI, or a dashboard, a message that you generate from the dashboard to the system. And you can also have some specific data type that is managed with special tools, so they need to be addressed with specific tools. So regarding high-level type, I mentioned that for each of the elements, I mentioned some slides ago, it may be needed to have a classification of the point of interest, and the classification of point of interest is correspond to the representation in the ontology of the data that you are going to collect. This is very important to classify the elements that you may have in your city. So in this case, the point of interest could be also sensors and all the elements that you may have in the city that are geolocated. So we have in the KM4City, that you see here, the ontology that also allow you to classify this element in two manners with in terms of nature and subnature. There are about 20 different natures and 500 different subnature in total, not for all not for each nature. Each point of interest is instance is usually defined as an element of a set. So when you have for a given kind of point of interest, for instance, the set of banks in an area, or the set of trees, or the set of benches, or the set of restaurants, etc. So you have a collection of elements in the city, and you may have more than one collection for each entities, more than one collection of school, one collection of restaurants, one collection of educational support, one collection of schools for languages, for foreign languages, and so on. For each element of the collection, you may need to have a location in latitude and longitude. For each collection itself, you may have nature and subnature, and a set of attributes. Typically, the location is specific for each element while the nature and subnatures is associated to the collection itself. So it doesn't change. For each element, you may have different attributes. For instance, the web page, email, opening time, phone, etc. So all these data are typically collected as open data in your infrastructure. You may have their open data as well. So to give you an example of what I am talking about, the single sensor, the single element of a collection, or the single MyKPI of your area could be very, very similar. For instance, they have a different high-level type MyKPI or sensor. Nature could be different, industry and manufacturing from one side, the other from IoT device to knowledge base. The subnature, chemical or IoT sensor, value type, density, percentage or battery level, value name, chloroparaffine is the kind of name of the variable measured. Data type on float, the value unit is a percentage, on the other side is a voltage. Last date and time, last value, could be a float in this case. Healthiness could be good or red if it's not good. Last check-in time, last time that has been checked as a value. Maybe the ownership could be private or public, and the organization at which these data belong, for which has been loaded. The device, the MyKPIs are typically single value, while they can be grouped in multiple value. While a sensor is an element of a device. For instance, this is a sensor. Oops. Let me do a different example. this is a sensor. This is a sensor and has been taken at this date and time. This sensor, temperature one, is a part of, is a measure performed attached to a device. The device is the device called Dev45, is a measure and includes some attribute like the date of observation, temperature, humidity, and other variables as well. So this means that a device has a relationship one-to-n with the sensors. For each device, you may have a multiple sensor. For each MyKPI, you may have only one value, and in both cases, the values change over time. So it's possible to have multiple measures changing in the time the values. In these slides, you see the classification on how you can ingest the most available high-level type, not only the sensors. So at the beginning, we started addressing only the real-time and static and dynamic value. We are now talking of more complex high-level type, like call to APIs, call to external service, call to micro application, matrix related to heat maps, synoptics, specific tools such as traffic flow reconstruction or typical trends for some variables, traffic flows, color maps, etc. All of them are specific high-level types. They are a larger set with respect to what is addressed by each single tool. So there is no a tool that is may address all of them. Almost all of them, in any way, are addressed by the data inspector and also by the dashboard wizard. So in this case, you see that they could have some GPS information associated with. They may be static and dynamic. They may also present a time series. You can imagine to have an evolution over time of the heat map. You may have an evolution over time of the traffic flow. Most of them are quite complex to be managed. On the right side of those kind of table, you can see how they can be ingested, how they can be changed, how they can be managed. So any data arriving in the platform is classified according to this table with that see on the left side the high-level type, nature and subnature. We already discussed about that. Value type, value name, data type, and value unit. I am making an example in the next slides. And the last data time on which we received the last value. So this is an information regarding real-time value. The healthiness criteria and the last check for at which the criteria has been tested. The owner and the organization are information typically accessible only for administrators because the single user belongs to only one organization and can see only his own data or the data that has been delegated to him. So it is very management aspect, the information, what is behind the status part. So this is a legenda explaining the meaning of the aspect. You don't need to have them explained, so we can go ahead and see one of them each later. So what you can do in your application to ingest. Let me return a little bit behind. For example, value type is degree of Celsius. Value name is battery temperature here. data type is a float, and the value unit is centigrades. So it's possible to characterize each value precisely and the date of and time of the last value received. So it's very fine-grained mechanism to characterize each value that is going to enter in your platform. So in the Snap4City platform, you can collect data by using two approaches, IoT application or ATL process. As already mentioned, the ATL process are practically deprecated, so we are trying to substitute them with the IoT application that are faster, easier to be used, and so on. So IoT applications are created directly on the browser. You can have on edge and on cloud a huge number of protocols with respect to the large number of protocols of the ATL. It can be scheduled internally. It can be, the ATL can be scheduled with an external scheduler that is called dishes. It's much more easy to have a IoT app because the scheduling is performed directly by who is creating the process, while the scheduling of ATL process has to be done by the administrators, and sometimes this creates confusion. It is largely, the IoT app are largely diffused. There is a large number of microservice actives for those kind of tools. It works for push and pull. It is very simple mechanism for other features. It's very diffused in the area of IoT. It supports both static and dynamic data model, and you can add many features. You can scale on cloud. It is also present on IoT Edge. So most of these features are not presently here. They have been very diffuse for a while in the past year, but are presently demanding two resources and not flexible enough to be continually used. So when it's possible, they have to be substituted. So data ingestion strategy and tools is the topics of the next section. So we already stated that we are working and focusing the activity in this section on this particular area, how to bring the data in the knowledge base and in the indexing. So this is the workflow describing how to ingest the data inside. So when you have a data set, it may came from a CKAN or may arrive you with some database, with some Excel file. You have to see, you have to ask it yourself that is a database for a table representing some regular structure, or it is a static information of a dynamic information, or is it just a static information. For instance, if the information that you would like to ingest is just a point of interest, it has only some static information that is not going to produce real-time data in the future. For instance, the position of the restaurants are not to be updated, and you don't need to. You are not going to have a sensor value attached to that restaurant or to that position of that part of city furniture in the roads and so on. So this is the first point. It is a point of interest, or is something that is going to change. If it's a point of interest, or is it something that is going to have some real-time data. If this is a point of interest, you have to see if the the structure is regular or not regular. If it is regular in terms of is regularized, and we are explaining better later what does it mean to be regular, it is if it is fit to a regular structure with the table that we are going to provide, you can just upload, and the tool can generate this, ingest the table and bring this information. You can have some direct process to bring this information in the knowledge base, exploiting a tool that we provide. This tool, it is discussed later. The alternative, if this is not regular, you need to regularize. You need to regularize, and if you, when you regularize, you discover that that is not possible to regularize, means that you have to address in a different manner. So everything that is not a point of interest, and so you need to address as a sensor. You may split the information in two, with registering in a first phase the static information on the IoT directory with the activity. You may need to register also a broker, or to register a device in a broker, and so this is